Chapter 11, Day 3, we're going to go ahead and find the area of irregular shapes, meaning shapes that we don't really know or have formulas to find the area of. So if we take a look at examples 1 and 2 while we take a look at the steps, as you can see, we don't have a formula for finding the area of this type of shape. So what we're going to do here is we're going to go ahead and break it into known shapes as step 1. So if we take a look at example 1, we can either make this so that we have a rectangle here and then a rectangle here and here, or we can go this way so that, again, we have a rectangle here, rectangle here, rectangle here. I'm going to go ahead and go this way. Again, you could go either way. You just got to be able to find the area of those individual shapes. So with that, step 2, find the area of these individual shapes. So I'm going to call this one shape A. I'm going to call this one shape B. And I'm going to call this one shape C. I want to find the area of those individual shapes. So for shape A, we have a rectangle. Finding the area of this rectangle, we know the formula is area equals base times height. So in order to find this area, we got to know the base, which they give us, is 7. That's the area for this rectangle. And then the height remembers that distance at a 90-degree angle from the base to the opposite side. So we know that this one is 3. Putting those together, the area of shape A would be 21 units squared. Awesome, done with shape 1. Shape B, finding the area of this shape. Again, it's a rectangle, so we just got to use the same formula, base times height, but the lengths are different. Let's start with the base. We're already given as 3. That's the full length of that bottom side. Now we need to find the height. Now be careful, because what I have seen in the past from some students is they want to just put the 9 as the height. But if you look, 9 is only the distance from the base up to this point. And if you go across, notice that's not the full length of that rectangle. So even though this is 9, it doesn't represent the full height. But in order to find this extra distance right here, we are given it inside that first shape we were talking about. So this extra 3 here would be that length. Knowing those from our first semester, part plus part equals whole, we can recognize that the height of the entire rectangle would be 12. So now we can plug those into our formula. Base is 3, height is 12. Multiply them together, you end up with the area of that second shape is 36 units squared. Okay? The third shape for C is another rectangle. So if we look, the base is again 3. Now that's not always going to be the same. That just happens to be in this case. And we have the same situation going on where 9 doesn't necessarily represent the height, but only part of the height. And we can use the same approach on the last one to fill it out so that we know that the full height of that rectangle is actually 12. So the same thing, because that's the case, we know that their area would be the same. So the area of that third shape is going to be 36 units squared. Now, we have the individual areas. Step 3 is that the total area is just adding those individual areas together. So we got the area of the purple, blue, and green. The total area is 21 plus 36 plus 36. If you add them all together, the total area of this irregular shape is going to be 93. Don't forget units squared, because we're talking about area. That is our unit of measurement. Looking at number 2, it's called a compound figure because they already broke it up for us into the 2 shapes that we need. Let's go ahead and start with the easy one where they give us everything we need to know. For the rectangle, the area of the rectangle, we have the base and height, so we can say the area of the rectangle is 10 times 7 because that's base times height. So the area of the rectangle we know is just 70 centimeters squared. Nice and easy, real quick. Now we got to find the area of the triangle. Remember the area of the triangle formula? We haven't done it yet, so we're going to do base times height over 2. We did that on day 1. Remember that for the triangle, when you're talking about base and height, those 2 things have to meet at a 90-degree angle. So if you notice, we have our 3 sides here, but the only 2 that meet at a 90-degree angle are right here. So we have the base here and we can make the height here. So let's call this one the base. So as we fill out this formula, we can say the area of the triangle is 6 times height. We still got to find that over 2. So this is the one spot we got to find. This would be the height because they meet at a 90-degree angle. Now we don't have that height, but what we can do is, from the looks of it, we can take a look at that triangle itself and create a right triangle to help us find that height. If you look across from the rectangle side, look straight across, we know that this length is 10. On a right triangle, we know that leg squared plus leg squared equals hypotenuse squared. So we can use the Pythagorean theorem, h squared plus 6 squared equals 10 squared, to find that third side. We're using old knowledge to help us find the length of that leg. Going through the process, h squared equals 64. Square root, just like we did in the past, h would have to be 8. So now we can plug that in for that third side, and it gives us the height. So if we plug that in, now we can use the area formula. You get 48 over 2, which is just 24 centimeters squared. Now that we have the area of the two shapes, the total area is going to be the adding of the two together. 70 plus 24, you end up with 94 centimeters squared. So that's how you find the area of those two compound figures. Okay, again, rectangles, I guess, and a triangle. If we take a look at number 3, again, a compound figure, break it up into the two shapes that we're talking about. So you can see we have a triangle here, and then we have a nice half circle or a semicircle here. So let's start with the triangle. So the area of the triangle, we just said, was base times height over 2, so we'll use that formula again. Fill out what we know. We know the height, because that's the distance from the vertex of one of the corners to the base of the triangle, and it creates a 90-degree angle. So we have the height is 10. We got to find the base, all over 2. If we look at the base of the triangle, we know that this half is 5. So then, because it's the radius of the semicircle, we know that that other half also has to be 5. So because those two parts are 5, we can state that the base is equal to 10. Plug it into your formula. You can get 100 over 2. So the area of that triangle is going to be 50 inches squared. So again, all we did was we took the formula, and then we used the knowledge of the height and then the knowledge of the radius to find the diameter, which represented the base of that triangle. Now, if we look at the semicircle, we can state that the area of the semicircle is going to be the area of the full circle, but divided by 2, because a semicircle is exactly half of a circle. So if we have the area of the full circle and divide it by 2, then we have the area of a half a circle. So in order to find this, we first have to find the area of what would be the full circle if we finished it out. So let's go ahead and find the area of the full. The area of the full would be the radius, so pi times the radius, which is 5 squared. So the area of the full would be 25 pi. Plug that in your calculator. You end up with 78.5. Now again, that's the full. So in order to get the half, divide it by 2. Take the 78.5 divided by 2. You get 39.3 is the area of the semicircle. Now, the total area, again, of the entire compound shape, you just add those two together, the triangle, which is 50, plus the semicircle, which is 39.3, and you end up with 89.3 inches squared. So that's how you find the area of compound figures, when you're trying to find a new total area that is made up of individual shapes that we can find. On the next page, we're going to go ahead and take a total figure and subtract interior areas to find the area of a shaded region. So those are our 3 steps. Step 1, find the total area. Step 2, find the non-shaded region. And then step 3, you would take the total, subtract the non-shaded, and what you're left with is that shaded region. So if we take a look at number 4 here, it's asking us to find the area of this shaded region. Well, nowhere in any of our notes can we have a formula to find the area of these types of shapes. We don't have it. So what we want to do is go ahead and take this full area, this part right here, and if I take this full area, which is everything, and I subtract the area of this circle, and I just get rid of it, what you're going to be left with are those shaded regions. So in order to do that, we have to go ahead and find the area of that full square first. So let's go ahead and do the area of the square. That's the full part. Making it look kind of nice here, but the area of this everything all together is again base times height. Well, the base is going to be 10. The height is also going to be 10 in this case. So we have 10 times 10. The area of the entire square is going to be 100 centimeters squared. But we want to get rid of that circle part. So the area of the circle is going to be pi r squared. So we need to know the distance from this center to the edge, but they don't give us it or anything inside the circle. But what we do know is that this circle is inscribed in the square. Because it's inscribed, we know that the diameter is equal to that, the diameter is equal to the side of the square space. So the diameter has to be 10, which means that the radius is half of that length, making it 5. So the area of the circle is pi times r squared, which is 5 squared. So the area of the circle is 25 pi, which in your calculator is roughly 78.5. In order to find the shaded region, all we do is we take the total square, which we said is 100, and we subtract out that circular part, which is 78.5. And when we do that, you end up with 21.46, again, centimeters squared. So let's watch this happen on the actual diagram. We have the blue part. That's the whole thing. We take the red part, which we just found is 78.5, right? And when I take away that red part from the blue part, what you're left with is just that blue part. Okay? So that's how we end up finding the area of that shaded region. For the example 5, the last one we're going to do here, it's very similar, except now we're just dealing with 2 circles. So let's go ahead and do this again. We want to find the area of the large circle, which is this full part. So that full area, which is not only the shaded region, but it's also including the white region. Oh, I don't want to cover up that 9. So that's the whole area we're going to find. It's pi r squared, and the radius, the distance from the center to the edge for that large one, is going to be 9. So we have the area of the large circle is pi times 9 squared. You end up with 81 pi, which in your calculator would be roughly 254.5. 254.5. So that's the area of the entire thing. If we take the area of the small region, which again is just, I didn't want to get rid of that, but that's just this part, that's what we're taking away. The radius for that circle is only going to be 4 because it's a smaller circle. So it would be pi times 4 squared, making it 16 pi, which in your calculator is going to be roughly 50.3. Now, once we have that, so that's the full, we want to take away that green part. And what you're left with when you do the total for the shaded, when you take the total, which is 254.5, minus the small region, which is 50.3, you're left with 204.2, again, feet squared. So by doing that, you are getting that shaded region we're actually looking at.